Okay, today we're going to start on chapter 3, paragraph 1, 2, and 3, and that is basically about reactions. Okay, the first thing that you need to know is that the reaction, we always say reaction, but basically it's called chemical reaction, because there are also physical reactions, and you will probably learn that in physics. A chemical reaction is a reaction where one or more substances react to turn into one or more other substances. Basically, there are two types of reactions that you need to know for now. Endothermic and exothermic. I'm just going to write that one down a bit lower so that I can actually add something to the endothermic one. Okay, so an endothermic reaction is a reaction that basically needs energy. That means that you have to add energy to keep the reaction going. Like, for example, if I want to boil water, basically it's not a reaction, but it is a process. When I want to boil water, I need to constantly add energy, because if I remove the energy, or in this case the heat source, it will stop reacting. There are more endothermic reactions, like the decomposition of water. This basically goes with electricity. You know that What Woman Want movie, where this guy falls into the bathtub with a hairdryer and then all of a sudden knows what woman wants. Okay, so that's not gonna happen, but the water is going to decompose due to the electricity. We constantly need energy, so it's either heat, but it can also be electricity. An exothermic reaction is a reaction that produces energy. And an exothermic reaction, for example, is the combustion of wood. Basically, all combustion reactions are exothermic because it produces energy. You can recognize both of them, like this exothermic reaction. How to recognize it is the temperature gets higher, and here the temperature gets lower. Here it gets cold, here it gets, obviously, if it gets warmer, if the temperature rises, then it obviously gets warmer. There are some things that you need to know about a chemical reaction, and the first one is the law of conservation of mass, which means before is mass after. It is completely impossible that something gets lost. Too bad you cannot lose mass. Mass can turn into something else, but it will never ever be lost. So mass before reaction is mass after reaction. It's the same as baking a cake. I add like milk, sugar, and eggs. Okay, I'm not gonna make cake with milk, sugar, eggs, and flour. I'm probably gonna make pancakes, but hey. And I turn this into pancakes. What if I add 100 grams of milk, 100 grams of sugar, 100 grams of eggs, 100 grams of flour. I get very weird pancakes, I know. 100 plus 100 plus 100 makes 400 grams of pancakes. It's impossible that something gets lost. It is possible that it evaporates, but it cannot get lost. The thing that you write down here is basically what we call a chemical equation in words. A chemical equation in words describes the reaction in words. Chemical reaction in words. Because we are a bit lazy in science, we prefer to do things as shortly as possible. That means that if I write down a chemical reaction, I can say the water decomposes into hydrogen and oxygen. I can, but as I said, we would like to do it short. So I'm going to write down substances before, arrow, substances after. In the case of the decomposition of water, I can say, okay, substances before, in this case, is water. Substances after is hydrogen and oxygen. So I can make water, arrow, hydrogen plus oxygen. And in this way, you can write down a chemical equation in words. It looks like this. Substances before, an arrow, substances after. If you have two or more, then you just add a plus in between of them.